Hey everyone, have you ever really stopped to think about what happens to all the water that goes down your drain? You know, we use it, we treat it, and then we just kind of let it go. But what if that wasn't the end of its story? Today, we're diving into a massive hidden resource that's flowing right under our feet. And trust me, the sheer scale of it is probably going to blow your mind.
Get this, 40 billion. That's how many gallons of wastewater our cities in the US treat and release every single day. Now, to put that into perspective, that's enough water to fill the Empire State Building over 150 times daily. It's just a staggering amount. And for the longest time, we've basically treated it as something we just need to get rid of. And at the same time, the places we normally get our water, rivers, lakes, those underground aquifers, they are under some serious pressure. We're all seeing the headlines. From the Colorado River to major aquifers, these lifelines for our cities are shrinking. It's a huge challenge, especially with our cities continuing to grow. So this is where the whole conversation just flips on its head. Instead of always looking further and further away for new water sources, what if we just looked down? What if we saw that 40 billion gallon a day flow not as waste, but as the single largest, most reliable, and most local water source we could ever hope for? That's the core idea, really. Beneath every single one of our modern cities, there is this massive, predictable river. And the best part? It doesn't depend on whether it rains or if there's enough snowpack in the mountains. It is always there. And now we finally have the technology to unlock it. Okay, so the official term for this whole thing is water reclamation. But let's break that down. It's just the process of taking all that used city water and cleaning it to such an incredibly high standard that it's safe to be used again for all sorts of things. This isn't just basic filtering, it's a complete transformation. So how in the world does that transformation happen? Well, it's not magic. It's a really sophisticated, multi-step journey that's designed to remove everything we've added to the water, basically hitting the reset button and returning it to a pristine state. Let's walk through it. The whole process works in layers, kind of like a series of security checkpoints. First up, primary treatment, which just screens out all the big stuff. Easy enough. Then, for secondary treatment, we bring in an army of helpful microorganisms. Think of them as a biological cleanup crew, and their job is to eat up all the organic waste. Then you get to tertiary treatment, which is the really high-tech polishing step. And finally, disinfection, using powerful UV light or chlorine, acts as the final safety gate to make sure any stragglers are gone. It's a thorough, redundant system for a reason. And to really appreciate just how powerful that tertiary treatment is, we have to zoom in on these two technologies. On one side, you have microfiltration. It's like an incredibly fine microscopic sieve that catches bacteria and other tiny particles. But then you have reverse osmosis. And folks, that is on a whole other level. It uses intense pressure to force water through a membrane so fine that basically only pure H2O molecules can squeeze through. This is how you get that exceptional level of purity. Okay, so we've done it. We've created this incredibly pure water. The next big question is, now what? What do we do with it? And this is where the whole thing goes beyond just treatment and starts becoming a cornerstone of a much smarter, more resilient water system for our cities. This reclaimed water is a total workhorse. It's used to irrigate farms growing our food and to keep city parks green. Industries use it for things like cooling and manufacturing. It can even be used to refill those stressed-out underground aquifers we talked about earlier. And here's the most crucial point. Every single gallon of reclaimed water used for these things is a gallon of precious fresh water we don't have to take from a river, saving it for what's most important, drinking. All right, let's talk about the elephant in the room. That psychological hurdle. Some people call it the ick factor. The idea of reusing water that was once wastewater. It can feel a little strange, right? So the most important question of all is just how clean, how safe is this water really? And this is where we just have to trust the science and listen to the experts. Public health officials have been studying these systems for decades. This multi-barrier process isn't just a casual suggestion. It is a rigorously engineered system with one goal: total safety. And believe me, the standards are incredibly strict. And honestly, the data brings it all home. Just look at these numbers. For pathogens, the standard for both is non-detectable. Of course, that's a non-negotiable. But then look at clarity or turbidity. The reclaimed water is often 10 times clearer. And dissolved solids, it can be more than 10 times purer.
This right here, this is the aha moment. The water isn't just as good as conventional water. In many key ways, it is a higher quality product.
So what does all this add up to? Well, it's about building smarter cities. It's about building more resilient cities. By reclaiming our water, we create a local supply that isn't at the mercy of the weather. We give our tired rivers and lakes a much-needed break. We build resilience. And we turn what used to be a liability, wastewater treatment, into a valuable asset. It's a truly circular system. So, the next time you see a storm drain, or just think about the water leaving your home, maybe you'll see it differently. Not as waste that's just disappearing into a pipe, but as the beginning of a journey. As part of a hidden, powerful river that's just waiting for us to tap into it. The question for our cities isn't really if we can do this anymore. The real question is, how quickly can we embrace it?